Now, what if we have, for example, 3 variables involved? Let's see. Suppose we have the following scenario. For f of x, y, and the third variable like z, which depends on x and y, equal to 0, we can take the derivative of these variables with respect to others. For example, partial derivative of z with respect to x is going to be minus f of x divided by f of z. Partial derivative of z with respect to y is going to be minus f of y over f of z. Well, you might be interested in finding the partial derivative of x with respect to y. You're going to follow what you did as before. Let's take a look at one example here. This example says you have x cubed plus y cubed plus z cubed plus 6xyz minus 1 equal to 0. You want to know what is the rate of change of z with respect to x at any point? What is the rate of change of z with respect to y at any point? So since there is a combination of x, y, and z, and you cannot isolate the z on one side, since we have a combination of x, y, z, and z is not isolated, we use the implicit differentiation. Okay, we have some nice formulas. Let's just follow them. Partial derivative of z with respect to x is negative. Partial derivative of f with respect to x. The derivative of x cubed is 3x squared. This is just a constant, so it's going to be 0. This is just another constant, it's going to be 0, and plus 6yz divided by partial derivative of f with respect to z. It means that x and y are equal to a constant, so the derivative is 0. The derivative of z cubed is 3z squared plus 6xy. Partial derivative of z with respect to x, you can distribute this negative sign to the numerator or to the denominator, or just leave it as it is. Of course, you can simplify by factoring out 3. It is negative x squared plus 2yz divided by, here you have z squared plus 2xy. Now partial derivative of z with respect to y. Let's follow the formula, the negative sign in front of it, then on the numerator you have the partial derivative of f with respect to y. So with respect to y, it means that x and z are constant, so we're left with 3y squared plus 6xz divided by, the denominators are going to be the same, 3z squared plus 6xy. Let us factor out 3y squared plus 2xz divided by z squared plus 2xy. So we found the partial derivatives, the rate of change of z with respect to x and y.